Let's now look at user authentication with JSON Web Token and refresh token to manage our sessions. We're going to add the users table and the endpoints to create, list, update, and delete the user before moving on to the login. With our login, we'll look at how to hash our password, have our login endpoint return the JSON Web Token, and lastly manage our session with the refresh token. And you'll see what session management is about in a bit. Before we start with anything, I understand some of you might not be too familiar with JSON Web Token, also known as JWT. JWT is basically a signed token that consists of 3 different parts, as you can see in this picture. The 3 parts are color-coded, separated by 3 dots. First, we have the header part. On the right, you see the header JSON with the algorithm and type fields. And on the left, we have the base64 encoded output of the header that comes before the first dot. And because they're base64 encoded, they can easily be decoded, meaning they're just readable to anyone when the signed token is exposed. And then we have the payload. Payload is also known as claims, and claims are pieces of information that asserts or claim about our subject. When we say subject, we are referring to the user that is logged in. So this JWT is used to identify users that's logged in and authorize them to only access resources scoped to that user. And again, this payload is base64 encoded, so you don't want to include any sensitive information there since it is readable by anyone once the token ever gets exposed. And lastly, we have the signature that makes this JWT more secure. We're passing in 3 arguments into our HMAC SHA-256 algorithm, and HMAC stands for hash-based message authentication code. And SHA-256 is the hash function used in this algorithm. We won't go into details on how this algorithm works, but all we have to know is that this is a symmetric keyed hashing algorithm, meaning that the same secret key is used to encrypt and also to decrypt our data. So inside this HMAC algorithm, we pass the base64 encoded header, base64 encoded payload, as well as our secret key, which is that symmetric key that we're using to both encrypt and decrypt our data. And because this is a symmetric keyed hashing algorithm, it is important that our secret key is not exposed to anyone. So now that we know what a JSON Web Token is, let's have a look at how the login works. When we log in with our credentials, our API will return our JSON Web Token that is signed with that HMAC algorithm. So next time we hit an endpoint that requires authentication, we pass a token in the authorization header along with the bearer keyword. This is also known as the bearer token authentication, and only when this token is validated, the API is going to return the relevant response. However, there are issues with access token alone. We want our token to have a short lifetime because there's a chance that it can get intercepted and exposed. And a short lifetime means that the user has to log in every 10 to 15 minutes when the token expires, and that is not a good user experience. So we introduced another token called refresh token that has a longer lifetime of say 24 hours, and it is stored in the database. The refresh token comes with a variable isRevoked that allows us to revoke the token if the token is ever stolen. And this refresh token can then be used to renew the access token through the renew endpoint. So we don't want to use either the access token or the refresh token, but instead use a combination of the two because each has its pros and cons. In simple terms, access token enables quick validation, while the refresh token allows us to revoke the token in case our token gets exposed. An access token enables quick validation because we self-validate locally in the code without querying the database. An access token is short-lived, and it is good in a sense that it prevents further damage by an attacker if the token ever gets stolen. However, the disadvantage is that the access token cannot be invalidated because it is stateless by design. Unlike access token, refresh token is long-lived, and it is good in a sense that it doesn't need to be frequently renewed. And the refresh token can be easily revoked, but the disadvantage is that it requires querying the database, so it is not a good fit to replace access token entirely because we don't want to be querying the database every time someone accesses an endpoint. I'm going to start from where we left off, and I might skim through some of these stuff that I've already covered in the previous videos. But even if this is the first video you're watching, you should still be able to follow along. The first thing I want to do is create our migration files, and we can do that by running this migrate image and calling the create command, specifying the directory of our migration files, and lastly the name of our migration file. So we have these new migration files created here, and I'm going to paste that SQL query that I've already prepared. Inside our users table, we have the ID, name, email, and password, as well as a boolean to identify if the user is admin, and our email is going to be a unique field. Then inside our down file, I'm going to paste this query to drop the table. We're going to start from the bottom in the store layer, and I'm going to start from defining our user struct. So inside our types.go file, I'm going to paste our user struct that has the ID, name, email, password, and so on. And remember, we need these DB tags to map each of the fields in the struct to the fields in the SQL query. And then I'm going to go into the store MySQL file and paste these methods that I have already prepared, since we have already done this many times. We have the store method to create the user, get the user with the email, list the users, update the user, and delete the user. With create user, we are calling named exec context, and we have this insert query where we insert name, email, password is admin with these values. And at the end of the method, we pass in our user struct that's passed in as an argument here. And then we retrieve the last insert ID from the SQL result and manually store the ID into our user struct because this ID is auto-generated. With get user, we simply call get context. With list users, we call select context. And this will make a select query on the users table and store the list into the slice of users that we pass in as an argument. Down here, we have the update user that makes a call to named exec context. And lastly, we have delete user. That's simply an exec context call. And then we can move up one layer into the server file. And at the bottom here, I'm going to paste this again. We have the server calls to create the user and so on. And as I mentioned in the previous video, all our server methods do is call its corresponding store method. And the reason we want to keep it minimal is because we want to replace our server with a gRPC server in our later video. Now we can move up to the handler layer. And I'm going to start by defining our user request struct as well as the user response struct. Here we have the user request struct that we're going to use to decode the request body into, as well as a user response struct that we'll use to send our response back to the user. And the list user response is really just a slice of user response here. And this time we have these JSON tags here to help us map each of the struct fields to the fields of the JSON request body. And once we have defined our struct, we can move on to the handler file, scroll to the bottom. And please bear with me, I'm going to paste what I have already prepared to save us some time. And this handler method is really similar to what we have done in the previous videos. So I'm going to skim through the parts that I've already covered in the previous videos and spend more time on the parts that's new in this video. So what we are doing here is reading the request body into our user request struct that we just defined. And here we want to hash our password before storing our data in the database. And because our server.createUser takes in a store.user as its argument, we have this helper method to convert our user request struct into our store.user. So we pass our user request struct into this helper method and pass that down into our createUser method. Down here we have something similar to convert the store user back into the user response struct. And once we convert that created user from the create user call, we can generate this response and send it back to the user in the JSON response. So let's see how we can hash our password. Inside the root of our project, I created this directory called util. And inside here, I'm going to create a file called password.go. I'll name my package util. And down here, I'm going to create this function called hash password that accepts a password string as its argument. And to hash our password, I'm going to use this package called bcrypt.generate from password. And inside that method, we're going to pass in the slice of byte format of our password as well as the cost. So this cost is a measure of how many times to run the hash. And I believe 10 is the default cost that's provided here. And this will give us a hash password as well as an error. And if there is an error, we can return an empty string and an error saying something like error hashing the password. Save that real quick and return the string format of our hashed password as well as nil. So you see this package hasn't been imported all I have to do is open my terminal and run go mod tidy. And down here, I'm going to add a function called check password that takes in the password as well as the hash password as its argument and return an error if there is. And all we have to do is call bcrypt.compare and hash password. And we pass in the hash password as its first argument and the actual password as the second argument. And that's all you have to do. I'm going to save this file. Now we can move back to the handler file. And down here, I can call util.hashPassword and pass in the password. This gives us a hash password as well as an error. So if there is an error, I can return an error saying error hashing password, and then we can manually assign this hash password into our password field. Now we're done with the create user. So I'm going to move on to the list users, update and deleting the user. Again, I'm going to paste what I have already prepared to save us some time. With our list users, all we're doing is call the server.listUsers, then iterate over these users, convert each of this user struct into our user response, and append it to the list of users in our list user response. With our update user handler here, we're going to read from the request body for now, but we'll later get the user email from the token payload of the authenticated user. And then we get the user information using the email. And with this user and the user request, we patch our user request. So if each of these fields is not empty in the user request, meaning that we receive a request saying that we want to modify this field, then we manually assign this new user request name into our store user.name field. If the user is requesting to update their password, we are going to hash our password and assign that into our password field. And because our updated @ field is a pointer type, we have to convert the current time into pointer. And all it's doing is just returning the pointer type of the time. So once we patch our user request, we can call server.updateUser and convert this updated user struct into our user response and send it back as a response. For the delete user, we're reading the ID from the URL parameter and calling this delete user on that ID. And please note that we don't have an endpoint for the get user because I didn't find the need to call the get user endpoint, and we only need the server.getUser call with the user email when we are trying to update the user. And now that we have created all the handler methods for the users, we can move on to the login endpoint. I'm going to come to the bottom here, and as usual, I'm going to create this login user method that takes in the response writer as well as the request struct. And first thing I need here is the login user request struct. So I'm going to come to the types.go file here and paste the login user request as well as the login user response struct that I've already prepared. Back inside our handler, we can call JSON new decoder, pass the request body and decode the request body into our login user request. And then we can call server.getUser with our email from the user request to get the user from the database. If there's an error, I'm going to say we get an error getting the user. And then we can call util.checkPassword to pass in the password from the user request and the password that is inside our database and see if this returns any error. If there is any, we can return error checking password, or we can really just say wrong password. And if there's no error, meaning that the password is correct, we can create a token and return it as response. So this token is our JSON web token. And let's see how we can create this JWT. I have already created this directory called token in the root of our project. So inside our token directory, I'm going to create this file called JWT maker, name our package token, and I'm going to create this struct called JWT maker. This struct takes in a secret key as its variable, and I am going to have this new JWT maker that takes in a secret key as its argument. And down here, I'm going to make a method called create token that takes in an ID, email, as well as isAdmin boolean and the duration. this will return a string as well as a pointer to the user claim struct, which we're gonna create in a bit. And to create our token, we can call JWT.newWithClaims. And you might notice that VS Code tries to import this Golang JWT/JWT, but I want to use the latest version of this package, so I'm going to add v5 at the end of this. I'll save this file and run go-mod-tidy. And JWT.newWithClaims takes in a signing method as well as a claims interface as its argument. So here I'm going to say signing method HS256, which is our HMAC with SHA-256 algorithm that I mentioned in the slides. And then as its second argument, it takes in a claims interface type. So if we dive into the newWithClaims and go into this claims interface, it says claims represent any form of a JWT claim set according to this RFC definition. And it says that JWT claim sets represents a JSON object whose members are the claims conveyed by the JWT. And this doesn't make too much sense. And I would say the easiest way to understand claims is that claims are really just pieces of information that asserts or claim about our subject, which is the user that is logged in. And claims are just the payload or the information that we want to pass around. I'm going to close these. And inside here, we want to create our custom claims to pass in as an argument. So inside the token directory, I'm going to create this file called claims.go, name my package token, and down here, I'm going to create a struct called user claims. This user claims is going to have an ID, email, isAdmin boolean, as well as jwt.registeredClaims. So this registered claims, if we dive into it, is a structured version of the JWT claim set restricted to a registered claim names. And again, this doesn't make too much sense. So if we go into this link, it's saying that these claim names are registered in the JSON Web Token claims registry. And all it is saying that these fields, issuer, subject, audience, and so on, are predefined fields of a claim. So registered claims are really just a structured claim that they want us to use. And the JWT package also kindly gives us this example to use on how to create our custom claims. And as you can see, we embed our registered claims into our custom claims, and we can use this custom claims to create our claims and pass it into our method. So back inside our claims.go, I'm going to create a function called newUserClaims that takes in an ID, email, isAdmin boolean, duration, and this returns a user claims as well as an error. And here I want to call uuid.newRandom that will give us the token ID and an error if there is. And I want to create this UUID to pass it into the ID field of the registered claims. And if there is an error, I will return nil and an error saying error generating token ID, and down here return our user claims struct with email, ID, our isAdmin field, and our registered claims with our ID. Our subject is going to be email because we know that our email is unique. We have our issued at timestamp, which is going to be the current time as well as the expires at timestamp. And we'll return the user claims as well as a nil as an error. I'll first have to run go-mod-tidy to import that UUID package. And if I save this, it actually fails to import the time package for some reason. So I'm just going to write this manually. And I actually spelled this wrong. So I'm going to change that. And now we can go back to our JWT maker, and up here, I'm going to call newUserClaims, pass in the ID, email, isAdmin, and the duration. This gives us our claims. And if there is an error, I'm going to return an empty string, nil, and an error. And then we can pass in our claims into the newWithClaims. This gives us a token. And then we'll have to call sign string on this token and pass in our secret key in the slice of byte format. This will give us the actual token string that's signed. And if there's an error, I can return the empty string, nil, and an error saying something like failed to sign the token. And then I can return the token string, the claims, and nil. And down here, I also want to create a method to verify our token. So I'm going to name this method verified token and pass in our token string as its argument. This will return the user claims and an error. And we can verify the token by calling parse with claims. And if we dive into parse with claims parses, validates, and verifies, and supplies a default object implementing the claims interface. So this default object implementing the claims interface is our user claims struct. So we would be passing in our token string, and we pass our default object, which is our user claims struct, as a second argument. And then the last argument here is a key function. So if we look at key function, the key function will be used by the parse methods as a callback function to supply the key for verification. So this is a key function that they allow us to define to verify our token. And this key function has this function type that takes in a token as an argument and return an interface as well as an error. So I can create this function that takes in a JWT token and return an interface as well as an error. And you can customize this to meet your needs, but all we're going to do here is verify the signing method. And we can do that by doing token.method and verify this is a signing method HMAC. And this will give us if it's true or not. So we can check if it's not okay. Then we return an error saying invalid token signing method. And the reason we want to verify the signing method is because if you remember the structure of the JWT, we have the first part, which is our header, and the header has the algorithm field that we can specify what kind of signing method we want to use. And if an attacker ever gains access to our token, they can modify this algorithm field to misuse our token. And if there's no error, we can just return our secret key and nil. The parse with claims returns a token as well as an error. So down here, if there is an error, we can return an error saying error parsing the token. And then we can call token.claims. And this claims is an interface type. So we want to typecast this into our user claims struct. This gives us our claims, and we can verify if that was successful. So if that was not okay, we can return invalid token claims. And lastly, we can return the claims and nil. And now let's move back to the handler to initialize our token maker. So here I'm going to add our token maker, which is going to be from our token package and the JWT maker struct. And here we can call token.newJWTmaker and pass our secret key. And this secret key is going to be passed down here like this. And because our new handler is called from our cmd main.go file, we need to pass in the secret key from here. And we'll actually read the secret key from our environment variable. And we can do that by calling our environment flag package. And I'm going to call .string, specify the name of our environment variable. And I'm just going to pass in a default secret key for now. So the secret key has to be a minimum of 256 bits or 32 bytes. So I'm going to give a default value of something like this, and I'm gonna have 3 of those followed by 0, 1. And I want to verify that the minimum secret key size is 32. So I'm going to add this constant here and then make sure our secret key is not less than the minimum secret key size. I'm going to do a quick go mod tidy. And this .string method actually gives us a pointer to the string type. So we have to dereference it. And I actually forgot to add one more argument, which is going to be our description. So it's just going to say secret key for JWT signing. I'm going to save this file and I'm going to move back into our login user handler method. So here now we can call token maker .create token, pass in the user ID, user email if it's admin, as well as our duration of this access token, which will be 15 minutes for now. This gives us our token, our claims, as well as an error. We don't need claims for now, so we're going to leave this empty at the moment. And if there is an error, I can return an error saying error creating the token. And we can create our login user response struct, which will have our access token as well as our user response with the name, email, and the isAdmin boolean field. Then we can set our header, our status code, and send our response back. And before we move on to our last part to create the refresh token, let's add our routes. So in our routes.go file, I'm just going to paste what I have already prepared. For the user's endpoint, we have an endpoint to create the user on post request, list the users, update the users, delete the user, as well as an endpoint for the login. So now that we have added our routes, we can move on to our last part. If you remember from the slides earlier, the access token alone is not going to be enough because it has a short lifetime and we cannot revoke it if it ever gets exposed. So we want to introduce a new set of token called refresh token that we're going to store in the database, and we can use this refresh token to renew our access token. So to store our refresh token, we first want to create our sessions table. So I'm going to create this migration file using this create command. So we call this migrate image with the create command, and a name of our migration file is going to be add sessions table. This gives us a migration up file as well as a down file. But let me close all these tabs to make it more neat. I'm going to open this migration up file and paste this create table sessions query. One thing to note is that the ID of our session is not going to be auto-generated with this auto increment keyword here, and instead we're going to supply the ID into the sessions table. And please note that the length of the refresh token has to be at least 512. And then inside our migration down file, I'm going to add this query to drop the session table. And then I'm going to start from the bottom inside our store method. And I first have to add our session struct like this. We have the ID user email, the refresh token, a boolean to check if it's revoked, the created at, and the expires at time. Then inside our store MySQL file, I'm going to paste the methods that I have already prepared. Again, it's the same thing we call named exec context to insert into the sessions table. And then we have the get session, revoke session. That's going to update the sessions table and set the is revoked to 1. And lastly, we have the delete session to delete from our sessions table. And then we're going to move up to our server file. And down here, I'm going to paste our session methods to create, get, revoke, and delete our session. And then inside our handler, types.go file, I'm actually going to modify our login user response to return a session ID that's of string type. And we're going to return an access token as well as a refresh token. We also need to return the access token expires at as well as a refresh token expires at. Save this. And we also need structs for the renew access token request. And this is only going to take in a refresh token as its request. And also the renew access token response struct, where we're going to return the access token as well as access token expires at. Now that we have defined our structs, we can move back into our handler and we're going to modify our login user method a little bit. So I'm going to have the same method here to create refresh token. So I'm going to call this refresh token, and this is also going to give me a refresh claims. And instead of 15 minutes, it will have a longer lifetime, say 24 hours. And I also want to use the access claims in a bit. So I'm going to define this here. And down here, I can call server.createSession to store our refresh token in our database. So I'm going to pass our context as well as our store session. The ID will be the refresh claims.registered claims.id. The user email is going to be the email from the get user call. The refresh token will be our refresh token returned here. It's not going to be revoked by default, and the expires at time is going to be from the refresh claims.registered claims.expires at that time. This gives us a session as well as an error. And if there is an error, we can say there was an error creating the session. Then down here, we can return our session ID, which will be session.id. And we also have refresh token, which is our refresh token. The access token expires at from the access claims, and the refresh token expires at from the refresh claims. We can simplify this a little bit by just calling toUserResponse and passing in the get user. So now when the user logs in, the user is going to have an access token as well as a refresh token that they can use to renew their access token. So that is all we have for the login, and the logout handler is pretty simple. So I'm going to call logout user. That takes in a response writer as well as the request. And for now, we are going to read the session ID from the URL parameter like this. But we'll later get the session ID from the token payload of the authenticated user. And if this ID is empty, we can say missing session ID. And all we have to do is call server.deleteSession and pass in the ID as an argument. And if there is an error, we can return an error saying error deleting the session and just say status no content here. Now we are only left with two more handler methods to renew or revoke the token. So here I'm going to add a handler method called renewAccessToken that takes in a response writer as well as a request. So I'm going to have our renewAccessToken request struct and call new decoder and decode our request body into our request struct as usual. And then I can call tokenmaker.verifyToken to verify our refresh token. So I'm going to call this refresh claims. And if there is an error, I'm going to say error verifying the token. And then I can make a server.getSession call to get our session from our database. We can do that using the ID, the session ID from the refresh claims like this, and we get a session as well as an error. And if there is an error, we can say error getting the session. And we can check if this session is revoked. So if this session is revoked, we can also return an error. And one other thing we can do is check if our email is the same as our email in our refresh claims. And if that's not the case, we can say it's an invalid session. And if there's no error and we have validated the refresh token, we can call tokenmaker.createToken as we did before. And we're going to pass in the refresh claims.id, which is the user ID. The email is admin as well as the lifetime of our access token. So this gives us a access token access claims as well as an error. If there is an error, we can say there was an error creating the token, and then we can create our renewAccessToken response with our access token and the time our access token expires at. And lastly, we can set our header, our status code, and send the response back. And finally, we have our last method, which is to revoke our session. So revokeSession that takes in a response writer as well as a request. And the Copilot actually does everything for us. We're just going to read the ID from the URL parameter and call revokeSession on that session with the ID. So I'm going to save this file and go into our routes to first add routes for our logout endpoint. And down here, I'm going to add the routes for the tokens endpoint to renew and revoke the token. So now that we have defined all our methods and all our routes, let's go ahead and test the endpoints. So we first have to bring up our MySQL container. So I'm going to do docker run, specify the name, and just use this command that's saved in my history. So now if I do docker ps, you can see our MySQL container is running with name ecom-mysql. And I can exec into this container and pass in this query to create our database called ecom. And once I've created our ecom database, I can do docker run and run our migrate up command. So we are running the migrate image, specifying the connection string of our database and running the up command. If I press enter, that's going to apply the 3 migration up files that we have to add the users table and the sessions table on top of our init schema that adds our orders and the products tables. And now I can cd into our cmd ecom API and run our main.go file. I'm going to bring up Postman to test our endpoints. So we have our users endpoint and we're making a post request, and we can send this JSON request with a name, email, password, and the isAdmin field. So if I make this post request, you can see that the admin has been created, and we can also send a get request to list the users we have and make a patch request to update the user. For example, I'm going to update the name to say updated admin. So if I make this patch request, it's actually saying error getting the user because we're actually reading the email from the request body itself for the time being. So I actually need to keep this email field, and I'm only going to modify the name. And remember, we're going to read the email from the token payload in the future, and this is just what we have to do for the time being. So now when I send the patch request, you can see that the name has been modified. Now let's test our login endpoint. So we can make a post request to the login endpoint, and we can pass our email as well as our password. So our password is just password. So when we make a post request, we get our session ID as well as the access token, refresh token, and the time each of the token expires at. So as you can see, the access token expires in 15 minutes, whereas the refresh token expires tomorrow on the 17th. And then we can test our renew endpoint using our refresh token. So I'm going to create this new request to send a post request to localhost 8080 tokens renew and pass in our refresh token in our request body. So I'm going to have our refresh token field and pass in our refresh token as its value. So when I made a request, that validated my refresh token and gave me the access token I needed. And the last endpoint we want to test is the endpoint to revoke our token. So I can do localhost 8080 tokens revoke, and I'm going to pass the session ID as its parameter. So we have the session ID from this response here. So I'm going to copy this here and paste it as its parameter. And if I make a post request, I'm not going to get anything back as a response. And I actually have my database pulled up to show you that it worked. So right now our data has a 0 value in the isRevoked field. But once I refresh this, you see that the isRevoked has changed to 1. So this was a pretty long video, but I hope this video gave you idea on how to work with JSON Web Token and refresh token to manage the sessions. I hope you found this helpful, and thank you all for watching.